Unlock your potential today at skillbakery.com.
Welcome to another exciting video. In this one, we'll be understanding generics in Rust and we'll be using traits to constrain them. Generics allow you to write flexible and reusable code by abstracting over types. You can use generics in functions, structs, enums, and other areas of the language to handle different types without writing separate implementations for each type. By default, generics can work with any type, but you can constrain them by using traits. This means you can specify that a generic type must implement a certain trait in order to be used, ensuring that the type supports the required behavior. If you remember, in our previous lecture, where we were discussing traits, we had such implementation in place. If you see this print description function, we are saying that any type can use this function as long as it implements the describable trait. So here we are kind of constraining this T and saying that it is only applicable for types having this describable trait. Now, let's go ahead and understand generics using some easy to understand examples. So here I'll be creating a function which will just print the value that we are providing. It could be an integer, a float value, or it could be a string. First thing, we are including the debug directive so that we can make use of the question mark command in our println function. So here we have a very simple function which says print value. And then in our main method, we are using this print value to print an integer. And then we are again using the same print value to print F64 or float value. And finally, we have a string in place. Now let's save this and execute it using the cargo run. And then the bin flag is there because we have this file inside the bin directory and then the name of the file without the rs extension. So here you can see that we have the output 10.3.14 and hello world. So here T is a generic type placeholder. When you call print value, Rust infers the actual type of T based on the argument you pass. For example, over here we had I32, F64 and $str. The same function can now work with many different types without needing multiple versions of it. Now let's understand how we can construct generics using traits. Sometimes you want to ensure that your generic type can do certain things, like implementing methods or behaving in a specific way. This is where traits come in. You can use traits to constrain generics, meaning that the generic type must implement the specified traits in order to be valid. So here, you can take the same trait example and the print description method that we had, and you'll notice that here in our main class, we were making use of the print description on two different objects, book and person. So here, if I go ahead and now execute this file called traits, you'll get the output over here from these two lines, print description, book and person. First one says Rust programming by Steve Klapnick and Alice is 30 years old. So that's how we make use of traits to construct generics. Now let's also understand how we can use generics in structs and enums. So let's say we have a generic struct that can hold any type. For example, we have this struct called container and can hold any type of T. Now let's go ahead and implement this container. So here we can implement it and we are saying that container T is a generic struct where T can be any type. You can create a container to hold different types like I32 or str, and the getValue method returns a reference to the stored value. So I can make use of this now in my main method, and here I can say container new 42, and then another one as a string container where we're passing Rust or a string size reference. And now I can go ahead and make use of the println command to print these two. So here we have the println macro, and we are saying container.getValue and string container.getValue. So you'll notice that this container basically holds this type T. So we have created two containers, one for integer and one for string slash reference, and both of these can now access the get value. And if I go ahead and execute this one, you'll find these two outputs. int container holds 42 and string container holds Rust with an exclamation mark. Now there could be a scenario where the trade bound gets too long or complicated. To resolve such scenarios, you can use a where clause to make it more readable. So if I take one example where we have, let's say, a function, and this function has this compare and print, and it's taking certain parameters. So here you can see we have the where clause, and now it is showing the trade bounds after the where keyword. We can use this over here to compare either a string or integer values. So in my main method, I can write this compare and print, and here you will notice output when we will execute this using the cargo run bin command. Let's go ahead and import the format display as well. So here on top, I've included the debug, and I also need to include the display. Now let's go ahead and rerun it, and there you go. So here it says 10 is greater than 5 and apple is not greater than banana. So to summarize, generics allow you to write flexible and reusable code that can work with any type. By default, generics can accept any type, but you can constrain them using traits to ensure the type implements certain behaviors. You can use generics in functions, structs, enums, and other areas of Rust. We can also trait bound generics to ensure that the generic type satisfies certain conditions. For example, implementing a trait. Using a where clause can make complex trait bounds easier to read. Generics and traits together make Rust's type system both flexible and powerful while maintaining type safety. By combining them, you can write highly reusable and efficient code. If you find the video helpful, don't forget to like and subscribe.